Not broadcasting. One second, please. I think it's working now. Sorry about that. So the forces, the pivot is going to exert both forces, and that will be our vertical as well as horizontal. Vertical and horizontal, and you can also say that it will be because of our centripetal force of rotating plank and the second one will be weight of the plank. Weight of plank. So we can just draw an approximate figure for that. And we have a plank. So there will be two forces. One will be in vertical direction, FB, and another one will be in horizontal direction, FH. These will be two forces that will be acting on it. So now we are going to use our torque and acceleration, and then which is going to help us to find out the forces. Okay. So in the first part, let's find out the acceleration of the center of mass. Acceleration of center of mass, and we have a vertical acceleration. Vertical acceleration, which is our ACM, vertical, will be equal to over alpha times L by 2. Okay. And we know that our torque is equal to I times alpha. Okay. And this torque will be also equal to mg L by 2. And moment of I we already know. We substitute value of I, which is our 1 by 3 ml square is equal to our times alpha. One second. Let me do it otherwise. So we also know that our torque is equal to mg L by 2, and from here we can say our alpha is equal to torque upon moment of inertia. Now it is, we substitute it, we get this is mg L by 2, and torque is our 1 by 3 and ml square. So here mass goes by length, and this gives us that our alpha will be equal to 3g divided by 2l. Okay. Now we find out our vertical acceleration, that is our Let us call this as AV. Keep it as it is. So we get our ACM vertical, which is alpha multiplied by L by 2. Alpha is our 3G 2L L by 2, and L cancels out. So this will be equal to 3G by 4. And we come to the forces on pivot. Forces on pivot. So first is our vertical, and which we can write according to the second law of motion, Newton's, the F of y minus mg is equal to m, and we have this as ACM in vertical. Therefore we get that our F of y will be equal to our mg plus m, and we substitute this is our 3g by 4. So this gives us 7 by 4 times mg. And next is our horizontal. And horizontal is our, suppose, f of x will be equal to m times a of x, and which gives us m times 3g by 4, and this will be our 3 by 4 gm. Now we have two forces in x and y direction, so we can easily find out the resultant. Therefore we can say that magnitude of pivot force that is F is equal to fx square plus fy square and its square root. The angle between the two is 90 degrees, so cos 90 will be 0. Therefore we get this as our 3 mg by 4 whole square plus 7 mg by 4 whole square and its square root. This will be coming approximately as square root of 58 4 times mg. We can also find out our angle, that is our theta will be equal to tangent inverse of our y and in terms of our x, which gives us tangent inverse. Y is our 7 by 4 mg and x is our 3 by 4 mg. So mg 4 and 4 cancels out, so this comes as our tangent inverse of 7 by 4. So this completes all the questions. Sorry about this mix-up. There was some problem with the internet and the streaming got stopped. So ideally it should be a one session, so this live session got divided into 3 parts. My apology for that. So this completes all the questions for the rotational motion as well as the conservation of energy part. Thank you.